All right, so where we left off was we had x squared equals -9, so x equals plus or minus 3i. So now we have to list all the solutions. The first one we got was 1/3, right? So that's x equals 1/3, and then we got a -2, and then we've got plus. You can write the plus or minus. You don't have to write plus 3i and then minus 3i, but you can if you want, plus or minus 3i, and then you count them to make sure that it equals the degree. So we've got 4, and then the degree of the polynomial is 4, so we are good to go. All right, in the U-try, so go ahead and press pause, try the U-try. What happens, let me throw this in the trash, there we go, is, okay, so I like this problem, this is interesting. So we go ahead and rewrite all of our factors of 85 over the leading coefficient of x cubed, which is 1. So it's just going to be all the factors of 85. So it's going to be plus or minus 1, 5, 17, and 85. If you look, there are no sign changes, right? Plus, 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 plus. That means there are going to be no positive zeros. So I am not going to try positive 1 or positive 5 or positive 17 or positive 85 because I know that there are no positive zeros. However, when I plug in negative x, I have 1, 2, 3 sign changes, which means I could have 3 or 1 negative zeros. So look at the degree is 3. So if I have 3 negative zeros, we're done. If I have 1 negative zero, then that means I have 2 imaginary because we have to have a total of 3 zeros. So I started with -1 and I plugged in, I said, all right, let me plug in -1 and see what I get. If I plug in -1, I'm getting 40. That means if I were to do synthetic division with -1, I would get a remainder of 40. It's not going to work. It's not a zero. It doesn't go in evenly. So the next number I go to is the next easiest number to plug in, which is -5. When you do that with synthetic division, you end up with a 0. Now, what's left is 3 numbers here. That's a trinomial. Now, it'd be great if we could factor that, but unfortunately, as soon as we look at that, we realize we can't factor it. So if you can't factor a trinomial, then you have to go to the quadratic formula or completing the square, which we're not going to do right now. So usually it's quadratic formula. So we do -b plus or minus the square root of b squared, no matter if b is positive or negative. When you square a positive or a negative number, b squared is always positive. That number is always positive. Minus 4 times a times c over 2 times a. And then when you simplify it, you get -4 plus or minus I. So the solutions are -5 and then -4 plus or minus I. And that means -4. That means -4 plus I and then -4 minus I, but you just don't have to write it out. Okay, moving on. We're on the last example. So given the polynomial function and 1 0, find the remaining zeros. Okay, well, if we have a 0 at 3i, then we also have one at -3i. That's 2 zeros right there. So what I'm going to do is I'm going to pick one of those zeros and I'm going to divide it into my original polynomial. Okay, so bring down my 3 and start. 3 times 3i is 9i. 5 plus 9i. You can't add the i's and the 5. Now I have to multiply 3i times 5 plus 9i. When I do that, I end up with 3 times 9 is 27, I squared. I squared is -1, so that's going to be a -27. And usually you write the number first, plus 15i, because 3i times 5 is 15i. And now I add those together and I get -2 plus 15i. And now I multiply. And when I do 15i times 3i, I get 45i squared. I squared is -1, so that's -45. And then I have to also multiply the -2 by the 3i, so I get -6i. And those 45's will end up canceling when I add them together, -6i. Hopefully these will cancel out because we know it's a 0. So 3 times 6 is 18, so that's going to be a -18, but then it makes it plus because we've got an I squared. There we go. We end up with 0. So it did go in evenly. Yay. All right, now we know this is the important part right here, okay? Once you use synthetic division and you divide a 0 out, you never go back to the original equation and divide out the next one, negative 3i, because you're causing a lot of additional work for you, and you're never going to get to a trinomial at the end where you can just factor and be done. So the next step is to divide the next 0 out of what's called the depressed polynomial. The next polynomial right here. This is a polynomial that we've divided one factor out of. Don't go back to the original. So now I'm going to start here, and I'm going to divide my next 0 that I know, which is negative 3i. So I go ahead and I bring my 3 down, and I get negative 9i, and this becomes 5, and this becomes negative 15i, negative 2. Now I know I'm going fast, but you can pause it, and you'll see that goes in evenly. What this means is 3x squared plus 5x minus 2. I really hope this factors. Wouldn't that be great? Then we wouldn't have to use the quadratic formula. All right, so the way I like to factor is by what's called guess and check. The first terms have to be 3x and x, because 3, a and c are prime numbers. So the easiest way to factor this is just by doing what's called guess and check. So I know that one of the original first terms here in each of these binomials, one has to be 3x and one has to be x, because there's nothing else that you multiply together to get 3x squared. Okay, so now the next thing I don't know, I don't really know the signs. However, I do know that the numbers here have to be a 2 and a 1, and I don't know where they go. Like the 1 could go here and the 2 could go here. I don't know. But when I multiply them together, the outer and the inner, I need to get a positive 5. So if I put the 2 here, what happens is I end up getting a 3 and a 2. And there's no way whether that 3 and the 2, unless they're both positive, which they can't be because this is a negative, this ends up being a negative 2. One of them has to be positive and one of them has to be negative. That's not going to work. So I'm going to try switching my 1 and my 2 around. What if I put my 1 here and my 2 here? Well, now I'm going to get 6 and 1. Well, that's awesome, because that way now if I make this a minus and this a plus, then when I multiply 3x times 2, I get 6x, positive 6x, and a negative 1 times x is a negative x. So positive 6x minus x will give me the 5x. That's how you factor using guess and check. You have to know how to do that. It is so important. If you do not know how to do that, please go back and watch some of my factoring videos on my channel and look at some more guess and check problems. What this means is that now we've got, using the zero product property, we can set each of these factors equal to 0. So, I mean, I already know x plus 2 equals 0. That's going to be x is going to be a negative 2. And if I do 3x minus 1 equals 0, if I add 1 to both sides and divide by 3, I'm going to get 1/3. So here are my solutions. 1/3, negative 2, and plus or minus 3i. And then that's 4 of them. Jeez. Why does that always happen to me? That's 4 of them. So then I go back up and I count. All right, my degree is 4, so we are good to go. All right, I think that's all. Let me just check here. All right, peace out.